What is up, Algebra 1? This is lesson 91 and also 94. Kind of just combine those together because they're covering pretty much the same idea here. But really we're talking about how do you solve and graph absolute inequalities. And how do you graph those on a number line. So just recall real quick that when we're talking about the absolute value of 3, that's equal to 3, and the absolute value of negative 3, that's equal to 3, because we talk about the absolute value, we're talking about its distance from 0. So notice this is negative 3, it's right here, and over here is positive 3. Its distance is 3 from 0, and this one's distance is also 3 from 0. But we're not talking just solely about equal to, we're talking about the absolute value of some variable is in this case less than or equal to 3. Remember, if we have less than or greater than or equal to, we use a solid dot, whereas these we use an open circle. Same idea, this is negative 3 here, this is positive 3 here. So since it's less than or equal to, I'm going to put a closed circle. And notice it says its distance from 0 is going to be 3 or less. So I know at that point it would be 3, and at this point it would be 3. And then any point in between, maybe like here, if it was here, that would be less than 3, right? Its distance would be less than 3. So I know any number in here, any number between those 2 points, would make that true. Now, on this next one we're looking at, it says the absolute value is greater than 3. So here's 3, and here's negative 3. And I know that its distance is going to be more than 3. So if I put it right there, that wouldn't be good. It has to be more than 3. So if I picked any number out this way, it would work, or any number out this way, it would work. Because the absolute value of any number over here, or the absolute value of any number over here, is going to give you a number bigger than 3. Alright, so let's actually do some of your homework here. So this one, number 1, says the absolute value is bigger than 2. So here's 2, open circle. Here's negative 2, open circle. I'm going to say, okay, it's bigger than that, so that means it's got to go to the right or to the left. Because any number that's in those arrow shadows would make that equation true. Number 2, here's 4, closed circle. Here's negative 4, closed circle. And now the absolute value of that must be smaller than 4. So its distance between 4, or between that number and 0, must be less than 4. So it's going to be between those two, because like absolute value of 2 is 2, which is less than 4. So any number in there is going to work. Now, taking this up a little bit, because now we don't just have the absolute value is greater than or less than something. We kind of have a little bit of an equation going on. So we're going to try to solve it. And we would solve it just the same way we would solve normal inequalities, except for at the very end. So first thing we want to do is we want to isolate or get that absolute value by itself. So on number 5, since the absolute value of n is being divided by 3, I'm going to do the opposite and multiply by 3. If I multiply one side by 3, I must do that to the other. These 3's right here reduce to just 1. So on the left-hand side, I'm going to end up with the absolute value of n is greater than or equal to, well, 4 times 3 is 12. So the distance between 0 and n is at minimum 12. So here is 12 units from 0, and here is 12 units from 0. And so numbers that are more than 12 units from 0 would be out this way or out that way. Number 7, still just going to isolate that absolute value by itself. So I'm going to subtract 7. Get the absolute value of x is less than or equal to 9. So its distance from 9, or its distance must be less than 9. Distance from 0 must be less than 9. So here's 9 right here. Here is negative 9 right here. And I know that its distance from 0 must be less than or equal to 9. So that's where it's 9. Less than would be numbers between them. Numbers between them. I'm going to do 4 more. They just have a few more steps in there, but don't freak out. You can still do that. And this gets where kind of the new concept here. So let's see if we can isolate that absolute value by itself. So I'm going to add 6 and add 6. So I'm going to have 2 times the absolute value of x minus 9 is greater than or equal to 14 plus 6, which is 20. The absolute value is still not by itself. It's being multiplied by 2. The opposite of multiplying by 2 is dividing by 2. So end up with the absolute value of x minus 9 is greater than or equal to 10. Now here is where I'm going to have to try to solve this. And if you logically think this out, it will logically make sense, but it's just a little bit complicated. So here we go. I'm going to write what's inside x minus 9, the same inequality, greater than or equal to same number. I'll have to solve that. And over here, I'm going to say what's inside x minus 9, the opposite inequality, opposite number. And then I'll have to go about solving that. So I'm going to add 9 here and add 9. So I'm going to have x is greater than or equal to 19. So that's up here. And over here I'm going to add 9. So I'm going to have x is less than or equal to, well, negative 10 plus 9 is just going to give me negative 1. Negative 1 is right here. And x is smaller than or equal to that, so this is going to go that way. Looking at another one here, I'm going to try to isolate that absolute value, so I'm going to add 3. So I'm going to say 7 times the absolute value of x over 8 is greater than 7. Divide both sides by 7 because this is multiplying. Those become 1 and those become 1, so I have the absolute value of x over 8 is greater than or equal to 1. So now I'm going to split this up. I'm going to say what's inside over 8 is greater than same sign, same inequality, same sign. Or I could have x over 8, what's inside, flipped inequality, opposite sign. X is being divided by 8, so I'm going to multiply by 8. So I end up with x is greater than, or just greater than, 8. Here's 8, so open circle, x is bigger than that. Over here, again, I'm going to multiply both sides by 8. I get x is less than negative 8. So negative 8 is here. X is smaller than that, going that way. Alright, number 17 and 18. Kind of same basic idea, except for it's just more steps here. So I'm going to add 8 here and add 8 here. So end up with 6 times the absolute value of 7r minus 3 is less than or equal to 108. Dividing both sides by 6. 6 is reduced. So I'm going to have the absolute value of 7r minus 3 is less than or equal to 18. I did that on my calculator. Now I'm going to split that up. I'm going to say 7r minus 3 is less than or equal to 18. Or I have 7r minus 3 is greater than or equal to negative 18. So again, it's what's inside, same inequality, same number. What's inside, opposite inequality, opposite number. Solving both of these, I'm going to say plus 3 end up with 7r is less than or equal to 21, dividing by 7. R is less than or equal to 3. Over here, adding 3. I get 7r is greater than or equal to 15. Dividing by 7. R is greater than or equal to, that's negative 15. Negative 15 over 7, which is just a little bit smaller than negative 2. So let's see here, 3 is right here, closed circle. And it's smaller, so it's going to go that way. That's like negative 2 and 1/7, so it's just like right here, going to the right. One more. Add 7 to both sides, because I'm trying to isolate the absolute value. So I have 3 times the absolute value of 4x plus 9 is less than 39. Divide both sides by 3. Absolute value of 4x plus 9 is less than 13. Now I can split that up because my absolute value is by itself. So I'm going to say 4x plus 9 is less than 13. Or I can, and I also need to say 4x plus 9 is greater than negative 13. Subtract 9. 4x is less than 4, dividing by 4. X is less than 1. That's half my answer. Subtracting 9. You end up with 4x is greater than negative 22. Dividing by 4. X is greater than, let's see, 11, negative 11 over 2. Okay, so here's 1 open circle. Negative 11 over 2 is going to be at negative 5.5. It's bigger than that one, so it's going to be colored in between, or like this. Alright, your homework is the rest of the worksheet. I've already done several of them there for you. So good luck, guys. You're going to do awesome.